Alright, hello everyone. I'm back with problem number 2 of this Physics C Mechanics multiple choice test with 35 questions. So this problem is definitely different than the first one. It's more conceptual, less mathematical. So here we're dealing with like the point of view of something falling relative to different people. So I'll read the problem. So student 1 stands on a cart holding a small stone. Student 2 stands at rest on the ground. The cart moves at a constant speed in the positive x direction, and student 1 drops the stone precisely when passing student 2, which represents the path of the falling stone relative to student 1 and 2. So I didn't have enough space on the page to include the little diagram they actually have on the question in the test, but essentially you can visualize there's a cart moving in the positive x direction. There's one person standing on the cart holding a stone, one person standing on the ground, and as the cart, right as student 1 who is standing on the cart passes by student 2, they drop the stone. So we're basically just figuring out like what that is going to look like to each of the students. So this is just a process of elimination problem. Um, so to start off with, let's just look at our answers. So A, it's going to look the same to both students. The stone is going to appear just to drop straight down. In B, oh, I forgot to label, but these are student 1, and these are what it's going to look like for student 2. So for A, student 1, it's going to look the same as student 2. For B, for student 1, it's going to look like the stone is falling straight down, and for student 2, it's going to look like it's like falling backwards. So same for all of these. Let's start to try to eliminate some options here. So we know that it's not like it's not gonna look the same for student 1 and for student 2 because student 1 is moving, student 2 is stationary. So student 1 and the rock are moving at the same forward velocity, and student 2 is stationary on the ground. So for student 1 as well as the rock, they're going to start with the same velocity, and when the rock is dropped, it's going to fall starting with the same initial velocity going forwards as student 1 is. So immediately we can get rid of A because we know that these are not going to be the same. The rock falling is not going to look the same for student 1 and student 2. So that also eliminates E because we know it's going to look different. So now we just have to figure out how it's going to look different. So for student 1 who is on the cart holding the rock, they start at the same velocity. So the rock and the student, that is, student 1 and the rock are moving at the same initial velocity. So that means when the rock is dropped, it's going to have the same forward x velocity that the student is having. So that means we know that it's going to look like it's falling straight down and not backwards to student 1. So that means, yes, this checks out. The rock looks like it's falling straight down to student 1. Yes, C also works for this case. The rock is going to look like it's falling straight down. But D, that's not going to work. We can eliminate D because it doesn't make sense for the rock to be falling forwards. If you're standing on something and you drop something, why would it go forward if you're just dropping it, you're not throwing it forwards? That doesn't make sense. So now between B and C, the only differences we have are the cases for student 2. So remember, student 2 is stationary, standing on the ground while this is all happening. So case B is saying that as student 1 drops the rock, to student 2, it's going to look as if the rock is falling backwards. Case C is saying as student 1 drops the rock, student 2 is going to perceive the rock falling forwards. So let's think about this. Let's think about this in terms of how student 1 sees let's perceive this in terms of how student 2 is viewing student 1, because we know that the rock is moving at the same forward x velocity as student 1. So if we can think about how student 2 is viewing student 1, we can think about how student 2 is viewing the rock. So student 2 is stationary. Student 1 is driving past student 2 on the cart. So to student 1, to student 2, it's going to look as if student 1 is going forwards, is going past them. So it's just going to be the same thing with the rock, because the rock is being dropped, but it's starting going forwards. Yeah. So it's going to be C, because to student 2, it's going to look as if the rock is falling forwards. So not a lot of math in this one. This is just kind of a conceptual problem, how you understand things relative to each other, how you look at kind of initial velocities, you could say. That's it. Thank you guys. Check back in for the next video.